So now the next topic we're going to learn is the queue. So queue is it's again a data structure. We're going to learn with the stack. Now we're going to learn queue. So here we're going to use queue, like we're going to implement using the linked list. Okay, that queue is being implemented. It's going to be implemented. Okay, so queue is basically a data structure. It's a linear data structure that allows insertion of element from the rear end and deletion from the front end. So we're going to insert. So there are two ends are there. Like unlike stack used to have, we're going to delete and insert from the top only. But in queue, there are two ends is going to be there. So one is going to be at the, it's going to go from that end. All right. The front end, like from front, is going to be deleted, and from the rear, it's going to be inserted. So it's work on the principle of FIFO, first in, first out. So whichever came first, that's going to be deleted first, right? It's unlike the stack. Okay, that is last in, first out. Okay, so example, people waiting in a queue. So you might have seen lots of applications that you keep your songs in a queue, or these all things are implemented by queue data structure. Okay, so where it's actually used, so it's been used in job scheduling, asynchronous data transfer between two processes. The queue is used for synchronization also. So handling of interrupts in the operating system, managing wait lists for single shared resources like printer or a desk, or order processing in a real-time systems. There also it's used. So it's used in the breadth first search in the tree and graph traversal algorithms. It's used in lots of places. Okay, so we're going to see that how is the implementation going to be done, how we're going to do by inbuilt data structure. We can implement how by creating those functions, by defining those functions from our side. How that's going to be done, we're going to see that thing also. Okay, so queue implementation, there are basically two main ways are there. So an array or a linked list. Okay, so we're going to see both things one by one. Okay, so array based queues are fixed size. Okay, the size of the queue is going to be fixed, which means that you can add only remove elements up to the size of the array. Whereas the linked list based queues do not have a fixed size. So which means that you can add or remove element as much as you want. So that's there in the queue implementation. Now, if you see, this is a queue, it's here, okay, and you can find it here that enqueue means adding element to the end of the queue. So there can be different naming also there. You might hear about, let's say, offer or poll. So that time I'll say, whenever I'm going to implement that time I'm going to make you understand what are those functions means. It's same as enqueue, dequeue maybe, right? Those things are there. So different namings of that same functionality is there. So we're going to see that also. So generally enqueue means adding element to the end of the queue, that is add. You can say it's add. This is an add function. So when we can enqueue in the front, that's in the front position, right? That's in the rear position. If starting position is here, so it's going to be entered in the rear position. That's insertion is going to be in the rear. Okay, now deletion of element from the front of the queue is going to be done. Okay, so we're going to delete it from here. So is empty function is going to check if the queue is empty or not. Is full function is going to check if the queue is full or not. Peak function is going to check like the value from the front of the queue without removing it. So this kind of is full, peak, is empty function we already applied in the stack. Here also we going to do that. So this is a queue, it has two faces, right? That the one is the rear and another is the front. Okay, now there are a few limitations of a queue. The queue is not searchable, so you need to maintain another queue to store the dequeued elements to search of an element. A queue traversal is possible only once. In this process, queue becomes empty. We need to take out the element one by one. That in that process it's going to empty it. So this is the theory about the queue. Now we're going to go and we'll try to write the code and we'll try to see how the implementation has been done. Okay, let's go to that part. Thank you. Now we jump to the VS Code, and here we'll understand how the queue data structure is working. So we're going to see the inbuilt data structure and we're going to create those all functions there by ourselves. So as we know that queue is a data structure that follows first in first out principle, meaning that the element added first will be the first one to be removed. And Java provides that queue interface and several implemented class in the Java util package to work with queues. So we're going to take that and we're going to implement queue by using linked list. Okay, so let me create one file and name it as q example dot java. I hit okay, it should be not created here. Control A X. I'll be coming out of this and I will be creating the in the queue folder. So I'll paste it here and I'll hit enter. Been created for us. Now what I have to do is I'll come down and here I'll write it as queue implementation using inbuilt function. Okay, and here we're going to implement this. So two classes I have to include, that is what I need to import, that is going to be queue and the linked list, because we're going to implement this queue using linked list. So queue is implemented by linked list. Others, like by other way also we can implement, but we'll implement using linked list here. So I'm going to write import java dot util dot queue. Okay, this is a class and I'm going to import one more file, that is import java dot util dot two classes we going to implement. All right, now this is the class we have. We're going to write the main method and we're going to go forward with it. So first of all, I'm going to write, let's say, public static void main method, and I'm going to pass the string array here. So it's going to be string, and we're going to write args. Okay, now this is done. I have to create a queue using linked list for the implementation. So what I'm going to do is create a queue using linked list implementation. Okay, so what I have to do is I have to create a queue. For creating a queue, you already know we already in the array list. Similarly, we're going to do that when we did in the stack also, right? So here I'm going to write what queue, and I'm going to write a string type. Okay, and here I'm going to give the queue name. So queue equals to new linked list we're going to implement. So I'm going to write linked list. Okay, linked linked list. This is how we create a queue. Okay, this is done. Now object has been created. The queue name is the actually object, and that is the queue name. We created that. Now we need to add the elements. Okay, so whenever we add elements using linked list, that time we use offer. So you may know that we use enqueue, dequeue also, enqueue for entering and dequeue for also entering. Similarly, offer is also the function that's going to be add element in the queue. And similarly, for deletion in a queue, it's poll, right, when we implement using linked list. So let's use that. Here we're going to do what? Add elements to the queue. Okay, so here what I'm going to write is I'm going to write queue dot offer, and I'm going to write, let's say, apple, the classic example. So let's take apple. What other fruits are there? Let's say orange, q dot offer. Here I'm going to write orange, and I'm going to write q again, and we're going to enter another value. Let's say offer type string we're going to give. This is going to give as let's say banana. Okay, it's going to be string, so I'm going to write it in string bana.
any. This is the addition. Let's say I need to print the queue, so I can directly write the name of the queue and it will print it. Or we can already know that if you want to print it, we can print in different by using the loop also that we can do, right? So here, if I want to print it, I will write, system.out, and what I want to do is here I'm going to write, let's say, queue. That is going to be what I have to write the queue name. I have to concatenate it and I'll write the queue, QUEUE. So this is from where it's going to print the queue. Okay, going to the next line. Let's suppose I want to get the element at the front of the queue without removing it. So what I have to do is, okay, this is going to be what? This is print the queue. Okay, now suppose I want to do what? Next operation I want to do, that is get the element at the front of the queue without removing it. So for this, we're going to take one variable that, let's say in the front, we're going to take variable and we're going to get it the first, that the front element that's going to be done by q.peek function that is there. There's an inbuilt function that's going to give, do the task, and we're going to print it. So for that, what I'm going to do is I'm going to take the string type, okay, and I'm going to give one variable that's going to be front, let's say, and I'll write q dot, peek function. Okay, this is the function we're going to write, and we're going to move forward. Now here I'm going to write, system.out.println. So system dot out dot println, and here I'm going to give that front element, let's say front element of the queue is, and that's going to be the front. That's going to be the front. That's a variable we have taken. So I'll write front here, and this is going to give the value. Now we're going to the next line. Now I want to delete the element from the front. So you already know that the deletion of the element is going to be from the front of the queue only, right? So here, remove the element at the front of the queue. So here again, I'm going to declare one variable of the string type. So let's say string type I created, and I'm going to name the variable as, let's say, removed element. So this is the variable we created. Now here we're going to do for removing, you already know that we will use the function that is the poll function that is there for the deletion in a queue. And for this, again, I'm need to print it out. So I'll be writing system.out.println, and here I'm going to write that removed element is going to be what? Removed element is, that is going to be the remove variable, like that is the remove element variable, right? So I'm going to write a remove element, and this is it for that. Okay, let's see for the next operation. Okay, suppose I want to update the value in the queue. Okay, so whatever the updated, so we did all these things. Now we want to print the updated queue. So for that, what I have to do is simply I'll print. So I'll only print the updated queue. So for that, what I have to do is I'm going to write another system.out println, and for updation, I'm going to, like, for printing the updated value, I'm just going to write the queue name. So updated queue is, what is the queue name? The queue name of our queue name is, that is the queue, right? So I'll be writing the queue, and it's going to print the updated value. Okay, this is done. Now I want to check if the queue is empty or not. So you know that is empty function is there, that is going to check if the queue is empty or not. So I'm going to check if the queue is empty or not. So for checking if the queue is empty or not, I'm going to type, let's say, boolean type I'm going to take, and I'm going to create one is empty function. After that, what I'm going to give is here, I'm going to write queue dot is empty is the function. Okay, this is the function. I'm going to check if it is true or false. It's going to give. If it is empty, it's going to give, it's empty. If it is false, then it's the queue is not empty. So here I'm going to write, system dot out dot println, and here I'm going to give one statement that is the queue is empty. Is the queue empty? So, and I'm going to question mark it, and I'm going to concatenate it, and I'm going to write the is empty variable that I have taken. So this will print yes or not, like true or false. Let's suppose I want to get the size of the queue. Size of the queue. Again, it's easy. That is the size function we'll use. Okay, for that one variable I will be taking, that is the size variable, and I'm going to write the queue name dot size function. This is a function, inbuilt function, then that's going to get the size of the queue. Okay, and I'll be using system dot out println. Okay, system dot println, and I want to get size of the queue is going to be what? The size variable we have taken. So whatever the size is going to be there, that's going to print the size, and I'll end the statement. So this is all about it. So it's going to print, some values to it. So I have, this again, white dots. I'll hit Control X and save it. Then I will click on either I can click on the run button, or I can click here. I'll click on the run, and it will run, and it will show the particular values. So from here you can see that, apple, orange, banana is there. Okay, then front of the, because it's printed first here, then front of the queue is what? That is apple at the first position. Then after deletion, because we deleted what? We deleted that's going to be deleted the front element. So apple is going to be removed. So orange, banana left. So is queue empty? No. What is the size of the queue? 2 is the size of the queue. So that is what it is printing for us. This is the whole operation for it. Now, this same thing can be implemented without using this offer function, then a peak function, then poll function. We're going to define these functions again. Okay, and we're going to see if that is working or not, and how to, what inside this offer function, what inside this peak function, we're going to see that, and we're going to implement all those things. Hope you've understood, and we'll move to the next part. Thank you.